Alright guys, this video is going to show you how you can set up multiple parts on a machine gun and have them all driven by one attribute. So everything works together, just to make animating a machine gun that much easier. So we could just drag this attribute here, this fire attribute. I'm going to hold control, middle click, drag, and we'll be able to see all the moving parts moving together. So we have a hammer strike, which is striking the bullets. We have some recoil. We have the shell casings flying out the side and landing in this circle, and also some ammunition being loaded into the side of the gun to replenish the chamber in there as well. So we also have a control here that's going to allow us to control the direction of our shell casing. So it will always land in this circle, and we can just move that circle around as well. The other thing we can do with this is control the turret. So we have a very simple no flip turret system set up as well, which is the same one we used in the tank rig tutorial if you followed along with that one. So we're going to get right into this. If you want to follow along with this model right here, go right ahead. I have the scene file up on my website. You can just download that. It's totally free. There's no sign up, none of that stuff. So you can just grab the scene file, and when you open it, it's going to look like this. Lots of stuff in there. Now you can also just use your own machine gun model as well. These four components, the hammer, the shell casings, ammunition, and the recoil, are going to be pretty much the main components of any machine gun. So you should be able to get this to work with your own model as well. But I do suggest that you use this model first, just so you can kind of make all your mistakes and do your whole learning process with this one. And then when you do your actual gun that you want to be rigging up, it's going to be that much better, right? So anyway, let's get going. So the scene file is broken down into 4 parts, just like we had with the tank rig tutorial, but this is going to be a lot easier than the tank, so we can get it all done in one video. So part 1, we're going to just deal with the turret. So I'm going to go ahead and hide part 2, 3, and 4. And let's take a look inside this group, and we have a whole whack of stuff right here. So the first thing we're going to do is set up our group hierarchy, so we have a nice clean area to start putting our rig together. So the first one is called MG, which just stands for a machine gun. You could call it top node or whatever you want to call it. This is going to be the group that houses everything. And we have a geometry group, a rig group, and a locator group. Now these groups we're just going to parent to our MG group. Going to move those in there. And we're going to parent the locator group to our rig group, as the locators are part of our rig. Now we have 5 joints that we're going to create. First joint is gun joint. Now you're going to place this one right in the center of your barrel, right at the tip. And this is also going to be used to emit particles or whatever you want if you're going to be using it in a game or whatever. So you can emit your actual projectiles from this. It's going to be a Z facing forward joint, just like every other joint that we create in pretty much every tutorial I'm going to be doing. They're always going to be Z facing forward. This is also going to be the joint responsible for our recoil. So the next joint is going to be a pitch joint. Now this joint is going to be placed wherever your hinge point is for your up and down motion if you're using a turret. The yaw, same idea. You want to place that in a pivot point on your model where you're going to be having your left and right aiming. And the base joint is going to be fairly static, but it will allow you to move and attach the entire gun to different components of a tank or whatever, wherever you want to put this gun. We also have a root joint, which is pretty standard, so we're going to parent everything to that. But before we parent those together, we're going to just skin the geometry to those components. Now in this model, I just have it set up fairly simple. We have our main machine gun barrel here, and that's just going to be skinned to our gun joint. I have a hotkey set up for just smooth bind up here. So skin, smooth bind. I'm just pushing a hotkey just to make this go a little bit faster. And I'm going to grab this pitch joint, skin that. Same thing with our yaw joint and our yaw hinge, skin that. Now we're going to skin our stand here to the base joint. Now we can go ahead and parent these pieces of geometry, all of these, into our geometry group, and we can parent these joints to each other. So we've got our gun joint to our pitch joint to our yaw to our base joint, and base joint to our root. We're just going to open that up for a little bit so we can see those joints. Now the next thing we want to do is deal with these locators. Now these are just here to set up a no flip turret system. So what we need to do is just create a locator on our yaw and pitch joint. I'm just going to name those pitch aim point and yaw aim point. So these locators are in the position of these joints, and then you want 2 more locators directly in front of those aim points there, and these are going to be your target points. So we have a pitch target here and a yaw target. Now you want to place these directly below whatever control you're going to be using to control your entire turret, your gun control. Now I just have a simple curve control set up here. Now on this curve control, I have one attribute that I've added. It's just a fire attribute, and this is a float. So to add this attribute, you want to go up to modify, add attribute, and you want to set it to float and just name it fire, and then just add it. And we're not going to put any limits on this attribute. So these locators go directly below that control, so they're right underneath. And then we also have another locator up here called our turret up object. And then you want to just move that up above the gun, probably like twice the height or something, just so it's out of the way. And now we're going to connect all these locators by using aim constraints. So you want to go to Constraint, Aim, bring up the window here. And we're going to be using a few options that we need to change. I think default, the aim vector is set to X. We want to hit 0 on here and Y, and we want to make sure Z is our main aim vector. So we want to set that to 1. Your world object type, make sure you set that to object up. And you want to put our turret up object, just copy that name and paste it into the world up object slot here. So now we can just select our blue pitch target point locator here and our pitch aim point and just hit apply. Now we're going to do the same thing for our your target and then our your aim, hit apply. Now they're set up, and now we're going to open up the point constraint window, and we want to constrain these two locators, our target points, to our gun control. So we're going to select our gun control and our target point, and then we're just going to make sure maintain offset is turned on, and we want to constrain all axes, and then just hit apply. And then we're going to select our gun control again, and now our your target point. Make sure maintain offset's turned on, and we want to turn off constrain all axes. Turn that off, and we want to constrain X and Z only. We want to leave out Y, and we're going to hit apply. So we can close that. Now let's bring up the channel box or the attribute editor here, and we're just going to lock that attribute to Y because we don't want that moving up and down, which will cause some issues with our turret. And the last thing we need to set up here is we need to connect our joints to these locators so that they all move together. So we're going to use an orient constraint for that. So we're going to go up to the menu here and grab orient constraints. And now we want to select our pitch aim point and our pitch joint. And we're going to just hit apply with constrain all axes turned on. Maintain offset is pretty much irrelevant because they're in the same spot anyway. So we're just going to hit apply. And then we're going to do the same thing with our your aim point and our your joint and hit apply. So we can close this. Now let's parent all of our locators to the locator group, and we can just hide that for now. Now if we move this turret, everything should be moving around like this. So nothing should flip. There should be no issues. It should just be rotating all the way around. Now we're going to move on to this MG control. There's no extra attributes on this or anything like that. This is just going to allow us to move it around and mount it to a tank or a robot or wherever you want to put this this gun. So the first thing we need to do with this one is just parent our gun control to that MG control because we want our target to move with this as well. And we also want to constrain our base joint, which is this one right here, to this control as well. And we're going to use a parent constraint. So let's open that up. We're going to grab our MG control and then our base joint, which is this one here, and then we're just going to hit apply. Now this will move with it. Now you see that there's something going on here. Something really weird is happening, and that's because we haven't connected our locators. Our locators are still staying in this spot. So we need to constrain our locator group as well to this MG control. So let's select the MG control and our locator group and just hit apply. So now when we move this around and rotate it, everything works. You can mount this on whatever you want to mount it on. You can have it in a hidden door opens up and the gun comes out. You know, whatever you want to do with it, you can do that now by connecting it with this control. So now part one is finished. We have a working turret. That was pretty easy to set up. We're just going to move our root joint into our MG group, and we're also going to put our MG control in our rig group because that's part of the rig as well. So once we have that set up, let's move out the MG group so it's out on its own, and we can delete this part one turret group. Now we can focus on part two, which is the firing mechanisms, the hammer and some recoil. So if we open this group up and unhide it, we'll see there's only two parts to this. So let's start with this joint here, the hammer joint, and we want to skin this to our hammer geometry here. So we're going to select that, and I'm just going to use my bind skin hotkey. So that's skinned. We're going to open up our MG group here, and we're going to parent our hammer geometry to our geometry group. Now our hammer joint is going to be parented directly to our gun joint because we want that moving with our recoil. So now we're going to animate this, and we're going to do this by using set-driven keys. So before we do that, we're going to quickly set a few keys on our gun control. And we're going to use the timeline as a pretty cool tool to help us set up these set-driven keys. So let's set a key on our fire attribute at frame 0. And then we're going to scrub to frame 10 and set this to 1. And then we're going to set another key. Now we want to go into our graph editor. We're just going to set that curve we created to linear. Just going to move that down for a moment. And now we're going to set our timeline to just 10 frames. And what this is going to do, if we hit play here, what's actually happening is we're firing just one shot. And that's going to allow us now to use these 10 frames to break this one shot down into tenths. So now we can move individual components within that one shot time frame. So we're going to have the hammer striking, the bullets moving in, some recoil, the shell casing. They're all going to happen within this one shot. So this is going to break this down for us and make it very easy to time out these set-driven keys. So let's go ahead and animate this hammer. Let's go up to Animate, Set-Driven Key, and bring up the Set-Driven Key window by hitting the Set button there. And everything's going to be driven by this control right here, which is our gun control. And we're going to be using the fire attribute, which is going to be the primary attribute to drive everything. So this is never going to change. It's always going to be the same thing in this set-driven key window. The only thing that's going to change is what we drive. So we're going to grab our hammer and load the driven. And we're going to make sure that we are using translate Z, which is this right here, because we want to be doing this motion. Now we're going to set a key at frame 0. So scrub the timeline to 0 and hit key. Then scrub it all the way to 10 and hit key again. So this is our curve, and we just created 2 keys on this at 0 and 1. Now what's happened here is we actually set those keys at 0 and frame 10, but we've got keys that showed up at 0 and 1. Now this is a set-driven key and not a regular key. This works very differently to a regular keyframe. So a regular keyframe is reliant on time. It's connected to time, right? When we're setting a regular key, we're setting it at a certain frame, a certain time. When you're setting a set-driven key, you're setting a key based on a value of another attribute, right? So we set it at frame 10, but this attribute right here was set to 1 during that time. So that's why we're getting that 0 to 1. And we're going to use that right now so we can break these set-driven keys down and make this a lot easier for us when we're putting this thing together. So if we scrub now to frame 1 and we set another key, and then say frame 3 and set another one. Now if we select this, we see they've shown up on 0.1 and 0.3, so it's relative to the timeline because we set it up this way. So it makes it very easy for us to get these keys down and start editing this. You'll see as we get through this, you'll see how much easier this is to work this way. So we want this hammer to smack the bullet, and we want it to happen very quickly, and then once it hits it, we want it to come back a little bit, maybe slightly slower than it actually took to strike it. So what we're going to do here is we're going to create this initial pop using this point right here. So if we move our timeline to frame 1, we can actually view this now by using this 0.1 key. We'll be able to move this up and shift this to where we want it to go. So now we want it to hit at this point. It's going to be a quick smack, so we probably want to put this to linear as well. So tangents linear, so it's going to be very immediate, and then it can just pull backwards slowly, maybe twice the time it took to actually strike. So now if I hit play, we're going to be seeing that hammer right away, and we can kind of get the feedback and understand where our animation's going. And now we're just going to do the same thing that we just did with the hammer. We're going to do the same thing to the recoil. So let's grab this. We're going to hit load driven. We're going to be driving our translate Z or Z. We're going to hit keyframe at frame 0 and another keyframe at frame 10. The reason why we keep doing the first and last frame here is because we want this to cycle. So we want to make sure our first and last frames are always the same. Now this recoil is going to happen after the hammer. So the hammer strikes, there's an explosion in the chamber where the bullets hit, and then that explosion causes the recoil. So we want to give a little bit of space here before we jolt this gun back. So we're going to go to frame 2, and we're going to set another key, shift one more frame forward, so 3, which will give us that one frame jolt back. So let's set another key there, and then we're going to give it 2 frames to kind of recover and get back into its regular position. So we're going to set a key there as well. So let's take a look at that curve, and we see it set up like this. Now if we move to this frame where we want the jolt, which is 0.3, we can just shift to frame 3, and now we can just move our curve point here, and we can get that position that we want it to recoil to. So roughly there will probably work. So now if we hit play again, we've got some recoil happening with our gun. That might be a little bit strong. Just gonna tone that back just a little bit. Something like that. There we go. That looks fine. And that's pretty much everything that we need to do for this part. So I'm just gonna move this down and let's get set up for part 3. So let's remove this group. We don't need that anymore, this part 2 group. And let's open the ammo box group, which is part 3. So if we unhide that, we see we have quite a few pieces here, but we're going to go through these one at a time. The first thing we're going to do is look at this bullet reel joint. Now this is a center point for a ring of bullets that we're going to set up right now. So we have one bullet here that has a pivot point set up where this joint is. I'm just going to duplicate that, and I'm going to rotate that 45 degrees because I want 8 of these in a ring. Now I'm going to be using a tool called Duplicate with Transforms, and I just have that set up with a hotkey. So I'm just going to keep duplicating this and then rotating it 45 degrees. So as I pound this hotkey here, it's just going to complete that ring for me. I'm just doing that so it speeds up this tutorial. Now I'm going to grab the original one as well. And now I'm going to use Mesh Combine up here. Mesh Combine, but I have another hotkey that I'm using just to speed this process up. So I'm just going to combine that right now as one piece. And I'm going to skin that to this bullet reel joint. Now this is the next thing that we're going to animate here. And we're going to be rotating on Z. So we want to add this to our load driven and select rotation Z right here. Now we're going to parent this joint to our gun joint, and then we can move our geometry into our geometry group. So let's go ahead and animate this reel right here. So the way we're going to do this is exactly the same way we were doing it before. So we're going to set a key on frame 0 and then another key on frame 10. And then we're just going to add some keys in the middle here. Let's just frame this curve so we can see what we're doing. And we're going to scrub to frame 1. Because we want this happening after the hammer strike, and we're just going to hit key, and then we're going to scrub to somewhere like frame 6 and set another key. Now what we want to do, what we're trying to accomplish with this animation is we want this reel to spin just 45 degrees so the next bullet is in place in the slot that it's supposed to go in. So it's just going to rotate 45 degrees. So we just need to move these last 2 points down 45. So we're going to go negative 45 here, and now if we hit play, we get those bullets now spinning exactly the amount it needs to spin for the next bullet to be in its correct place. So that's all in one place like that. Now I will mention at this point, if you have a very simplistic model that you're going to be using, like a very cartoony, chunky style, like maybe a tower defense game that you're working on, you might want to stop here and just use this as your ammunition. You might not even need to put a big curve of ammunition that's being fed into the side. This reel may be enough for you. You just might want to rotate it the other way. So we could just set it to 45 instead of negative 45, and you would have it kind of inside your gun that way. So if we hit play, it looks like it's feeding the ammunition in, just doing it that way. That may work for you if you've got a very simple model in that sense, like you're doing something very cartoony. But I'm just going to use them both in this situation. I wanted to show you this way as well as the curve, but they work very well together because this is just creating an illusion of a longer bullet chain, and we're getting 8 bullets for the price of 1 joint instead of having a joint per bullet like we have in the curve. So it's just saving some joint memory or whatever you want to call it. So let's put that back to negative 45, and now we're going to work on this bullet chain right down here. So we have a single bullet here just like we had with the reel, and we're going to duplicate that and snap it to the next joint that we have here. And then again, I'm using that duplicate with transforms. I just have a hotkey, and I'm just going to blast those out. I'm going to select all those and the original one, and I'm just going to combine those with mesh combine. Just have a hotkey set up for that. And now we're going to skin these bullets to these 12 joints here. So let's select these joints and our newly combined mesh, and we're going to go up to skin, bind skin, smooth bind. I would use the hotkey for this, but I just want to make sure that you're using max influences set to 1 and just hit apply. And now all of those bullets will be skinned directly to the closest joint, so you won't have any stray verts being dragged when you move this joint around. So it just saves us from doing any further point weighting. So everything is ready to go. So let's now use a tool that you can grab from my website. It's called Motion Chain. It's the exact same tool that we used on the tank rig tutorial to do the treads. I'll put the link below. So go ahead and grab that tool, and you want to drag it into a clean Python tab in your script editor. So I'm just going to bring up the script editor here, and I'm just dragging Motion Chain right now into this window here, this Python window. So I'm going to hit Control A to select everything and drag it up to our shelf here. I already have one up there, but once you let go, you'll get a button that shows up right here. But if you click that, you'll get Motion Chain window show up. So now we can set up this chain. So what we're going to do is we're just going to select our bullet curve, which is this one our bullets are going to be moving along. This is going to be our curve path. So let's just hit this set curve path button, and the name will show up right here. Then we're going to use this locator here, which is our bullet chain up object. And this object is going to be responsible for keeping our bullets facing forward. It's going to stop them flipping. So this is going to be our up object. So let's set that. And now we want to check the orientation of our bullet. So by default it's set to Z, so Z forward, but if we actually select one of these and hit populate, you'll see it's facing forward and moving along the curve, and we don't want it to do that. So what we're going to need to do is just shift our front axis to X, so we can just hit Control Z or Z and we can just repopulate that, and we can see now that it's facing the correct direction. So let's just undo that once more, and now we can commit to all 12 bullets right here, and we're just going to hit populate. Now the reason I did it like that and didn't set all 12 and test those is because this tool doesn't undo when you're using more than one object. It will just kind of mess things up. So you should really save before using this tool, even though I should have probably mentioned that before I used it. So let's move on now to the next part, which we might as well get the animation done here, because a new attribute has been added from this tool, which is cycle, which allows us to move this whole chain along using this attribute. So let's add this into our driver here, and we're going to use this cycle attribute. So let's link this up. So let's set our timeline to 0 and set a key. And then we're going to slide it to frame 10 and set another key. And now we're going to take a look at that in the graph editor. And let's highlight it and frame it. Now we want to set keys that matched our reel here. So we set one at frame 1, I think, and frame 6. Those keys should match that reel. And now we do need to shift this, just like we were doing the reel, where that shifted to the next bullet. But we're going to be doing it a little bit differently on this curve. So right off the bat, when we look at this and test this attribute here, you'll find that this curve isn't all the way to the end. So if we shift this cycle attribute, it needs to be at the point just before it disappears, which is right here. So it's 0.08. So we need to shift this curve 0.08. But because there's a little bit of an inaccuracy here, we want to do the math for that. So what we're going to do is we're going to take the value of 1, which is what it takes for one cycle, for all of these bullets to kind of recycle and go around once. Then we're going to divide that 1 by 12, because that's how many bullets we have on it. So that's going to give us 0.08 and a third. So we're about a third out on this attribute editor here. So what we're going to do is we're going to grab all of our points and we're going to shift them up 0.08 and a third. So just add some 3s there, and that should put us in the right spot. And now what we need to do is we want this whole one shot fired thing to put this bullet right to the end and shift the next one in the spot. So we need to now shift these last 2 points a further 0.083 repeating, just because that's the distance between these bullets, because we want to shift it one space over for one bullet, just like we did with the reel, but we're going to be doing it on the curve. So we're going to move these 2 points up further 0.0833. So that's going to take us to 0.1666666. And now it's going to make that bullet disappear because it's at the end. So now if we hit play, we're going to see the curve moving in the opposite direction as our reel, creating that illusion of a longer strip of bullets. And that bullet is going to be disappearing at the right time for the hammer to strike it. Just enough time for us to replace it with a shell casing that we're going to put in the next part. So let's stop that, clean up some of this stuff here, and finalize this part 3 ammo box. So we can close this for now because we're done with it until we go into the next part. But what we're going to do here is we're going to make sure all of these parts are now moving with our turret. So we're going to create one more joint here called bullet chain joint. That's just going to go at 0, 0, 0, 0. This is going to be the parent of all of our bullets. So we're just going to grab all 12 of those and parent it directly to that. And then we're going to parent this bullet chain joint to our root joint. So now we've got 2 separate mini hierarchies in here. One is for the gun and one is for our bullets. Now these need to be kept separate because they're dealt with differently. The curves create a little bit of a difficulty with the hierarchy, so they need to be just separated from the actual main gun stuff here. I'll show you what I mean by that in a moment. Let's get the rest of this stuff sorted out here. So this bullet curve here, this needs to have a cluster attached to it. So let's grab all of the CVs and we're just going to create a cluster. So let's go up to create deformers cluster, grab this little box here and make sure it's set to relative. We're going to hit apply. Now we're going to use a parent constraint with maintain offset turned on, and we're going to constrain this cluster to our gun joint. Now you can rename this if you want, you probably should. I'm just going to leave it as it is for now. And I'm going to grab our gun joint and our cluster and just hit apply. And then we're going to move this cluster into our cluster group and move this into our rig group. And we can hide that. Just going to move it up. Now this curve here is going to follow that cluster, so we can just move this curve into the curve group and also put that into the rig group. We can hide that as well. And now the bullet chain up object here, this locator, this also needs to follow the gun because it is controlling the flip of these bullets, and we need to make sure it's always above. So let's also constrain that. So let's grab this gun joint again and our bullet chain up object and just hit apply. Now when we move this turret, everything should move with it, and it's looking pretty good. Everything seems to work, and if we fire our gun up here somewhere, nothing's blowing up, everything should be fine. All our pieces are still moving. Great. Let's reset that. So let's talk about this joint thing I was just going to come back to. So if you look here, when I move this MG control, we still have our bullet chain joint set to 0. We haven't parented it to anything, and we don't want to. We don't want to combine it with anything or constrain it to anything, because we're just going to get this kind of weird stacking of motion occurring, and we don't want that. We need to keep that at 0. And one thing you should know about this root joint is this should be shared with whatever you're going to be combining this with. So if this gun is going to be mounted on a big giant robot, or whatever you want to do, whatever the root joint is for your robot, make it the same root joint here. So you can just parent these directly to that root joint. So just combine it with all the same root joint. Hopefully that makes some sense. All right, so let's move on now to part 4. But before we do that, let's just quickly parent this bullet chain up object to our locator group. I think we're done with that one now. And now we can delete this empty group and parent our bullet chain geometry to our geometry group. Close this. And now let's work with part 4, the shell ejection part. Let's also hide our root joint here. We don't need to have that showing. And unhide part 4. Now this part is going to be a little bit more complicated than the others because we're going to be dealing with the node editor and adding a few extra multiply divide nodes and things like that in. So let's get going on that. First thing we're going to do is the shell case joint. So you'll notice we just have the one shell case joint here. We're just going to be recycling that same joint. So every time it hits this circle, it's just going to hit the start again and just continue forever and ever. So that's what we're going to do with that. We also have a shell case mesh here that we're going to skin with a hotkey here to that joint. We can then place our shell casing geometry in our geometry group or parent it. Let's open up motion chain one more time and let's connect it to our curve. So the curve that we're going to be using is this trajectory curve right here. This is going to be our curve path, and we're going to be using this shell case up object, this locator right here, which is going to be positioned directly underneath our curve here to stop any flipping, and that's going to be our up object. So now we're going to grab that joint, shell case joint, and hit populate curve. Now we have the same issue we were having before where it's aiming down the curve, so we just want to set that to front axis X and repopulate it. And now it should sit in exactly the same spot as our bullet chain. Now we can grab our shell case up object and set that as our driven, and we're going to be using the cycle attribute again. We can close motion chain now, we don't need that anymore. And now let's animate this. So let's scrub back to frame 0 and hit key, scrub to frame 10, hit another key, and now scrub to frame 1, and we're going to hit one more key. So let's take a look at that curve in the graph editor, and it looks like this. And all we need to do here is just set the value of this last point to 1. And that's just the full cycle. All that means is it's just going to do the full cycle for one full shot. And we want to set this to linear. And that's it. That's pretty much all the animated pieces put together and timed, which is pretty cool. All we need to do now is just add some spin to this and set up this whole control here so we can move the shell casing. So let's do that right now. Let's set back to 0 here. And we're going to parent our shell casing to our bullet chain joint so that all those bullets are in the same hierarchy, separated from our gun. Next thing we're going to do is take our trajectory curve and we're going to create clusters in all the CVs. So let's go to CV mode and we're going to select the first CV and we want to go create deformers cluster and just hit apply with relative turned on. We're going to select the 2 middle points here and hit apply, and then the last point, hit apply again. Now we can close this. We have these 3 clusters that we've created. And now if I would have named that last cluster, this would have probably been named 1, 2, 3. So I'm just going to name these ones. And this is our shell case cluster 01. Just going to copy that and paste it into these clusters. So now they're all named. Now what we're going to do is we're going to connect these clusters to these controls that we have here. So you want to create a bounce control, which is just a curved circle. And I have that frozen 0 transforms, and the pivot point on it is the center of the circle, and it's set to snap right at the end of that trajectory curve, right in the middle. We have this peak control right here, and this is going to allow us to control the peak of our trajectory and have a little bit of control over the whole shape of it. There's no extra attributes or anything on that. It's just a simple transform. Now our main control here that we're going to be using to manipulate our shell case is this shell case control, and we have one extra attribute on this. It's called spin, and it's just a float attribute, so you can just add that with modify add attribute. Just pick float, and there's no limits on that either, so we can go in the negative or positive with that. Now we do want to actually limit the transforms on this controller, so we're going to go ahead now and select all of our transforms and deselect rotate Y. Then we can just lock and hide these, because we just want to use the rotate Y. We just want this. This is all we need with this control. And then we want to create a separate group that has a center point that matches this shell case. So I've created a group here. It's called shell case reset, and it's just zeroed out. The transforms are frozen just like the control as well, and they're in the same position. And what this is going to do is going to allow us to connect this control via a parent constraint to our gun joint, which is here, but also free up our rotation Y transform so that we can rotate it on top. So I'm just going to do that right now and show you what I mean. So we're going to grab constraint parent, get this parent constraint window open, and now we're going to select our shell case control, parent it to our shell case reset node here, which is in the same spot, then select our gun joint, and then our shell case reset node, and just hit apply. So now this will follow, see the arrow following? And we can still rotate this without any kind of weird parent constraint blocking our transform. So if we select the actual reset node, you see the constraint is using up all the transforms. Now because we parented to that node, we don't have that problem. We can still use that. So that's the reason we do that. So now we're going to move on to this peak control, and we're just going to parent this directly to our shell case control. So it should be inside there, just like that, because we want it to move with it. And now we can just go ahead and constrain our clusters to those three controls. So we're just going to take our shell case control and then cluster 1 here, our shell case cluster. And we're going to use parent constraints again and just hit apply. Same thing with our peak control and cluster 2. Just hit apply. And same thing with our bounce control here at the bottom and cluster 3. So let's just hit apply. So now when we move these things, these controls, we're controlling our actual trajectory curve right here. Okay, so let's parent these clusters real quick to our cluster group, get them out of the way. This bounce control circle here has its own reset node as well. It's just like the shell case one. It's going to be used a similar way, but the pivot is set not to where the circle is, it's going to be set to where the shell case is as well. So we want to be able to rotate this bounce control. We want it to move with this control, right? But we don't want it to move with our turret. We want it to be fixed on the ground. So this is what this bounce resets for. So what we're going to do here is parent our bounce control to this bounce reset here. And then we can just parent our bounce reset directly to our MG control in here. It's not going to be linked in any other way other than a quick connection now, which we're going to do in a moment. Our trajectory curve, let's just parent that real quick to a curves group. We're not going to be using that anymore. And this shell case reset node, let's just put that in our MG control as well, because it already moves around. Don't need to parent do anything else. So now all of our controls are all in the correct group. Now I'm just going to test the turret real quick, and we're going to take a look at what happens when we move it around. Everything's moving with it except our bounce point here, our bounce control. And we want this to follow it. We want it to spin around with our turret, but we don't want it to tilt and bend when we aim the turret. We want it just to stay fixed along the ground. So one way we can do that is with an orient constraint. And if you don't want to use the node editor, we can do it that way. But we do have a little issue when we use an orient constraint. So don't actually do what I'm about to do. I'm just going to show you what happens if you use an orient constraint. So what we're going to do is select our shell case control. Just going to go orient constraint, bring up the window here. Now select our bounce reset, and I'm just going to hit apply. So now when I move this, our control is moving correctly, everything moves with it. But if I move our turret with a slight angle to it, if I tilt our gun up and now rotate this around, what you're going to see is some weird stuff happening. See that? And it's just the whole stack of joints we got going on here. It's just confusing the constraint. So we shouldn't really use a constraint for this unless you're okay with that kind of weird issue. I'm not, so I'm just going to do it with nodes instead. So we're just going to undo this, and we're going to do it with the node editor. We're just going to do a real simple node setup and do it a different way. So let's open up the node editor right here, and we're going to turn off shapes because it's annoying. And now we're going to select our bounce reset, which is going to be the object that we're going to be feeding our information to. So let's add that, move it to the end here. Now we're going to add on our yaw joint, which is right here. Make sure you select that one and put that up. We're going to also add our shell case control, which is the arrow. Let's add that on there as well. And now we want to create a node. We're going to create so right click, create node. We're going to create a plus minus average. So you can go to utilities and scrub down till you find it. There it is there. Or you can just type here. You could just type in AE. There you go, AVE. There it is. It shows up right there for average. We're going to connect the y-axis from our shell control and our yaw joint, combine them, then put the result into our bounce reset node's y-axis. So let's drag our rotate y, put this into input 1D 0. We've got this weird unit conversion that pops up here. Then we're going to do the same for the yaw joint. Take our rotate y, plug that into input 1D1. That's in there. And then we're going to take that result, output 1D, and plug that into our rotate y. We can get rid of this, get rid of that. Now when we rotate this, we'll have it spin just fine, even if we tilt that gun up. We're not going to have any issues with that rotating. That's going to follow around, and then when we're aiming up and down, it's not tilting or causing any issues. It's not going with it, right? So this is the result that we want. So let's just reset that. That's all set up correctly. Now what we want to do is take our shell case up object, and we're just going to parent constrain that to our shell case control. So let's grab a parent constraint, then grab our shell case control and this shell case up object. I'm just going to hit apply with maintain offset turned on. And now when we rotate the control, everything is moving with it the way it should. Yay, we're almost there. We're so close. We just got one thing left to go, and that's just add some spin to this shell casing that's flying out the side there. So we can hide our root joint now. We can close our set driven key window now. We don't need this anymore. We're just going to be using the node editor again. So let's open that up. So we're going to add two nodes. Let's add the shell case control right here, and also our shell case up object, which is our locator. Let's just add that. So we're going to connect these with two other nodes. Let's create a plus minus average node and a multiply divide node. Let's rename these real quick. Just going to take that name and toss it at the top here, at the front. Shell case multiply divide. So first thing we're going to connect is our spin attribute from our shell case control. So this one right here, because we want to be able to control the spin on this manually as well, not just rely on a random spin. We want our shell casing to be aligned in this slot perfectly with the bullet every shot. So we can't just throw on some kind of random rotation here. It's not going to work. So every rotation is going to be the same. So this spin attribute is just going to allow us to move it around and create some variation if we need to. So let's connect this spin attribute to our plus minus average node. Let's grab spin, plug it into our input 1D 0, and now we're going to use our shell case up object. We're going to be using our cycle attribute to drive our main rotation, because it's a cycle, because it goes from 0 1 0 1 0 1, and it's going to ensure that our rotation of our shell case is going to match up perfectly every shot. So at 0, and this is 0, we want 0 rotation, so we're going to be using that, making use of it just to make sure that our shell case is aligned at the start. So I'm just going to take our cycle attribute, wherever it is, there it is, and we're going to plug that into our input 1D 1 right there. Then we're going to take the result of this plus minus average, and we're going to be using this to drive just one of these. We're going to be using it to drive our front twist. So if I scrub forward so we can see this. So this is the one that we're going to be controlling with our attribute. So we're going to connect this output 1D into input 1x, and then this output x we can then connect directly into our front twist right here. So now if we play this right now, nothing really crazy is going to happen because we actually need to multiply this value. So we're just going to have to pick something fairly high to multiply that 1 by. So I'm going to guess like 500 or something like that should be sufficient. So if we hit play, it's exactly what we want. And we can also use this to add some spin on the other axes as well if you want to. I did this on the original one I showed you at the start, so I might as well just add that now. So we're just going to take our cycle attributes and plug that into input 1y. And again, take the cycle attribute into input 1z and take the output y, plug this into maybe our up twist, and we'll take the output z and plug that into our side twist. Now we can just play with these values here. These are going to be a different value. I'm going to guess around, it's going to be a negative and not quite as high as this, so negative 300 should be okay, something like that. So if we hit play, we're getting rotation on all the different axes. You don't really need to add every axis, but I just threw that in there just to vary it up a little bit more. Now there's just one little minor thing that we need to do really quickly, and that is set our timeline back to 100 or something, or maybe 1000. And if we hit play right now, you'll notice that we just get one shot, but the timeline's still moving. What did we do wrong? We didn't do anything wrong. We just need to now set all of our curves to loop. So what we're going to do here is we're going to select all of the curves, the set-driven key curves, and group them in a selection set so we can access them very easily, so you can tweak each of them, and then we can set them all to loop as well, right? So first of all, let's remove the animation from our gun control here. Let's just delete that. Delete selected, because that was just a quick temporary animation we were using to build the set-driven keys. And now let's go into our display option here and just turn off DAG objects only, and you'll see all your curves. So you want to select every curve here that doesn't have the words motion path in it, because these are generated from our tool here, motion chain. So we don't need to worry about those ones. We just want to grab this one here, bullet reel, gun joint, hammer joint, shell case, bullet chain, and shell case up object. Now with those selected, you want to go up to create, sets, and then grab this little box here, and we can name this. We're going to call this set driven keys, and just hit apply. And now we can turn off our DAG objects only, and you'll see it right here. Now if we open this up, we have those curves and we have access to them. So what we're going to do now is just open up our graph editor, bring it up here, and we're going to select all of these. Now we can see them all together in one place, and you can start tweaking and shifting those curves around to play with your timing if you need to. But we're just going to take these curves, and we're just going to set them all to pre-infinity cycle and post-infinity cycle. So if we quickly put some animation on this attribute here, our fire attribute, I'm just going to set a key at 0. I think maybe 1000 frames was too many. Let's just go to 100. If we go to 100 frames, I think maybe 20 shots or maybe 15 or 16 shots should probably be fired in that amount of time. So if we hit play, we've got a machine gun that's continuing to fire, but you see it's actually slowing down and speeding up, and that's because our animation is non-linear, so we want that to be a linear motion. So if we hit play now, we have our machine gun firing and all our pieces moving together, and it'll just continue forever. Now there is one little extra thing I will mention. This bullet reel right now is only moving 45 degrees. It's going 45 degrees over to the next bullet, and it's popping back 45. It's 45, pop back, 45, but like this. So if you want this to continue around, maybe your bullets are all slightly different, you got different scratches on them or whatever, and you want them all to be rotating properly. What you want to do is just grab your bullet reel curve right here, and we're going to frame it, and we're going to set this to pre-infinity cycle with an offset, and post-infinity cycle with an offset. And what that's going to do is it will just continue the rotation. So that's everything that we need to do to set up this machine gun that works just like this one, with a hammer that strikes bullets and shell cases flying out the side, ammunition being loaded into the other side, and some recoil. Also the controls that we can manipulate our shell casing and our no-flip turret. So hopefully this tutorial helped you out in rigging up a machine gun. It should help you with any machine gun model. We may need to add some extra bits for certain models. Like if you have one of those big giant rotary assault cannons, you might want to add something similar to this bullet reel here at the front. But other than that, that's pretty much all I can think of that you may need to add to your machine guns. So yeah, this should cover any model. So hopefully this tutorial has been helpful for you. If you want to see more of this kind of stuff, please like, subscribe, drop me a comment. And yeah, happy rigging. Take care, guys.